Welcome back to Intellify. I'm Rasika Ramakrishna and let's continue with the chapter on polynomials. Exercise 2.4, question number 4. If the zeros of the polynomial x to the power of 4 minus 6x cubed minus 26x squared plus 138x minus 35 are 2 plus root 3 and 2 minus root 3, find the other zeros. Alright, so what are we given? We are given a polynomial of degree 4 and 2 of its roots. And what do we have to find? We have to find the other two roots. So why have I said other two roots? That's because biquadratic polynomial is going to have 4 roots and we have 2 roots, which implies there only exist 2 other roots. Alright, so how do we go about this? Okay, so if there exists a relation between the roots of the polynomial and its factors, that is, if using the roots somehow we can try finding the factors, then we can factorize this polynomial and from there we can go ahead and obtain the roots, right? So how are the roots of the polynomial and the factors linked? This is the important question here, which we will answer. Alright, so let's try and understand the relationship between the zeros and factors of the polynomial if it exists. Alright, so I think I gave it away, but okay. So let's take a polynomial 3x squared minus x minus 4, some arbitrary polynomial, and assume that we have to find the zeros of this polynomial. So you would go ahead, split the middle term, express it as 3x minus 4 times x plus 1 equal to 0 and equate each term to 0 and you will have x equal to 4 by 3 or x equal to minus 1, right? So these are the zeros of the polynomial. But let's take a quick step back and let's go to this step. So what are these guys called? What is 3x minus 4 and what is x plus 1? Well, they are called the factors. So let's quickly look at what this process is called. It's called factorization. So essentially you're breaking down the polynomial and expressing it in terms of its factors, and using these factors we find the zeros, right? So there is one sort of link, as in using factors of a polynomial you can find the zeros. So given the zeros of a polynomial, can you find its factors? Well, the answer is pretty simple, right? Because if a and b are the zeros, then x minus a and x minus b are going to be the factors. You can verify this fact. But here, if you want to just understand it on an intuitive level, look at this step. If you know that 4 by 3 and minus 1 are the roots of the polynomial, then obviously you know that the polynomial can be expressed as x minus 4 by 3 times x plus 1, right? About it for a while, it will make sense. So given a and b are zeros, we just said that x minus a and x minus b are going to be factors. So if x minus a and x minus b are going to be factors, then x minus a times x minus b is also going to be the factor, right? In most cases, it will be the polynomial itself, in case we're talking about 2-degree polynomials. If we're talking about higher degree polynomials, then this is definitely going to be a factor. So what do we mean by a factor? It will completely divide the given polynomial. Alright, so with this new information, let's look at the question we have. So alright, so now let's get to our question. So we are given a polynomial of degree 4 and we are given 2 roots of this polynomial. So how do we find the other 2 roots? Okay, so first I would suggest we look at this particular question. So assume that you are given a number and one of its factors. How do you find the other factor or factors? Say you're given 12 and you're given one factor to be 3. Obviously, you can say that the other factor is 4. That is, you don't need to know anything about 12 per se. You don't need to know that 2 or 6 or anything else is a factor. But you can immediately say 4 is a factor. So how did you say that? Well, because 12 divided by 3 is 4. So I mean, that example might have seemed pretty lame, but I'm getting to a very important point here, and that's why I used that example. So I'm saying that I'm giving you an additional hint as well. So whenever a quantity is divided by its factor, the remainder is 0. So we have the division algorithm. This is by the division algorithm. So whenever you divide something by a factor, the remainder is 0. So using these two facts, can we try and devise a strategy to find the other 2 roots of the polynomial? Well, first what we do is we divide the polynomial by the factor g, which is nothing but the product of the factors obtained from the 2 given roots, right? So now that you divide it, you will have the quotient. And what you do is you factorize the quotient and obtain the zeros. The quotient is also going to be a factor, right? Just like how in the case of 12 and 3, 12 divided by 3 is going to be 4, and 4 is also a factor of 12, right? So your quotient is also going to be a factor of the polynomial. So therefore you can factorize this quotient and obtain the zeros, and these zeros are going to be the zeros of your polynomial as well. Therefore, the given zeros plus the zeros obtained by factorizing the quotient are equal to the zeros of the polynomial. So spend some time on this slide to understand why we are going to go about this question in this way, but I'm sure it's pretty easy to understand. So now that we're equipped with conceptual understanding, let's go ahead and find the other two roots of the polynomials. So we are given 2 plus root 3 and 2 minus root 3 to be the roots of the polynomial f of x, which implies that x minus of 2 plus root 3 and x minus of 2 minus root 3 are going to be factors, which implies that the product will also be a factor. So this is, the product is nothing but x square minus 4x plus 1. So this is a factor of f of x. So now that we have a factor, we divide our polynomial by x square minus 4x plus 1, and the quotient obtained will also be a factor, and we will factorize that to find the remaining two zeros. So x square minus 4x plus 1 is the divisor, x to the power of 4 minus 6x cubed minus 26x square plus 138x minus 35 is your dividend. So go ahead with your polynomial division, and your quotient is going to be x square minus 2x minus 35. So now we factorize the quotient. So once we factorize x square minus 2x minus 35, we can write it as x square minus 7x minus 7x plus 5x plus 35 is equal to 0. So this you can write it as x plus 5 times x minus 7 equal to 0. So your x is thus going to be either minus 5 or x is going to be 7. Therefore, all the four roots of the polynomial equation are 2 plus root 3, 2 minus root 3, minus 5 and 7.